Bridget bought a bag of apples at the grocery store. She gave half of the apples to Anne, then she gave Cassie 3 apples, keeping 4 apples for herself. How many apples did Bridget buy? Okay, she had four, so four, and then before that, she gave away 3, so +3, and she gave half of the apples from that, half the apples to Anne. So whatever this number divided by 2 is 7, so that's 14. Um, how many apples did Bridget buy? Yeah, so it's this 14. I'd say choice E. On average, for every 4 sports cars sold at the local dealership, 7 sedans are sold. The dealership predicts that it will sell 28 sports cars next month. How many sedans does it expect to sell? Okay, so sports cars, sedans. So 4 sports cars, 7 sedans, 28 no, 28 sports cars. This is an increase in 7. So by a product of 7, so it should be an increase in a product of 7 for the sedans. So I'd say choice D, 49. The graph shows the constant rate at which Susanna rides her bike. If she rides a total of a half an hour at the same speed, how many miles would she have ridden? Okay, so she's going 1 mile in 5 minutes. So if she rides a half an hour, that's 30 minutes. So time multiplied by 6, that's 6 miles. So I'd say choice C. The 5 pieces shown below can be arranged to form 4 of the 5 figures shown in the choices. Which figure cannot be formed? So the figure that cannot be formed, this figure doesn't contain a block with 5 consecutively. So I'd say choice B, and all the others do. A sequence of numbers starts with 1, 2, and 3. The 4th number of the sequence is the sum of the previous 3 numbers in the sequence. In the same way, every number after the 4th is the sum of the previous 3 numbers. What is the 8th number in the sequence? Okay, so if we have 1, 2, and 3, then we have 6. Then summing these numbers, that's 11. Then sum these numbers, that is 20. Sum these, 31, 37. So number that we're at, this is the 4th number, 5th number, 6th number, 7th number. We want the 8th number, so it's going to be this one. Add these, 57 plus 11 is 68. This is the 8th number. I'd say choice D. Steve's empty swimming pool will hold 24,000 gallons of water when full. It will be filled by 4 hoses, each of which supplies 2.5 gallons of water per minute. How many hours will it take to fill Steve's pool? Okay, so 4 hoses, each supplying 2.5 gallons. So per minute, that's 10. It's doing 10 gallons per minute. So divide 24,000 by 10, and this is how many 10 gallons. This should be how many minutes. So 2,400 minutes it'll take for the hoses to fill. To convert this to hours, it's 2,400 divided by 60, which is 40. So yeah, I'd say choice A, 40 hours. The triangular plot of ACD lies between Aspen Road, Brown Road, and a railroad. Main Street runs east and west, and the railroad runs north and south. The numbers in the diagram indicate distances in miles. The width of the railroad track can be ignored. How many square miles are in the plot of land ACD? Okay, so it's going to be this full triangle minus the area of this one. So area of this triangle, this is 3, that's 3. 3 times 3 over 2 is 4.5. The area of this big triangle that's 6 times 3 over 2 which gives us 9. So the area of this shaded area is 9 minus 4.5, which is 4.5. So I say choice C. The length of a rectangle is increased by 10% and the width is decreased by 10%. What percent of the old area is the new area? So the length of a rectangle, let's just say it was like, yeah, 10 by 20. So the length of the rectangle increased by 10%. So it becomes, this will become, or rather length, let's just call it this. 10% of 20 is 2. So this becomes 22. This decreased by 10%. So minus 1, that's 9. What percent of the old area is the new area? 9 times 22 . 9 times 22, 180 plus 18 is 198. So that's 198 over 200, which is 99 over 100. So that is 99% old area is of the new area. Construct a square on one side of an equilateral triangle. On one non-adjacent side of the square, construct a regular pentagon as shown. On a non-adjacent side of the pentagon, construct a hexagon. Continuing to construct regular polygons in the same way until you construct an octagon. How many sides does the resulting polygon have? Okay, so we have 2 here, 2 from the square. Then we're going to connect the hexagon to this, like that. So then there will be 4 here, and then something is going to connect to this. So, or rather, no, not 4. This is 3 actually, 3 sides. Something will connect here, so there will be 4 sides, and then in the 7-sided regular polygon, 5 will be because that'll connect. But when we get to the octagon, one side will be connected, but then we will have we'll have not 6 but 7 sides because that then won't connect to another shape. So we can add all these numbers up. This is 7, 11, plus 5 is 16, plus 7 is 23. So I would say resulting polygon would have 23 sides. On a checkerboard composed of 64 unit squares, what is the probability that a randomly chosen unit square does not touch the outer edge of the board? Okay, probably it does not. So let's find the number that does. So there are 8 here, 8 here, and then we've included these edges, so 6 plus 6. So summing this together, 16 plus 12 is 28. So probability that it does not touch the outer edge, it's going to be the total number of squares minus the 28 that are on the edge. And this is over 64. 64 minus 28 is 36. And then this is, divide this by, this is 18 over 32, 9 over 16. Yeah, so I'd say choice D. The Amico Middle School bookstore sells pencils costing a whole number of cents. Some 7th graders each bought a pencil, paying a total of $1.43. Some of the 36th graders each bought a pencil, and they paid a total of $1.95. How many more 6th graders than 7th graders bought a pencil? Okay, so cost of the pencil has to go into 143. Cost of the pencil has to go into 195, and it has to go into the difference of 195 minus 143, which is 0.52. So if we look at factors of 52, that is 13 times 4. Prime factors are 13 and 2. 2 doesn't go into either of these, so I'd say cost of the pencil has to be 13 cents. How many more 6th graders than 7th graders bought a pencil? Well, the number more is just they bought 52 cents more. To figure out the number, it's 52 cents divided by 0.13, which is 4. Answer choice D, I think. Two spinners shown are spun once, and each lands on one of the numbered sectors. What is the probability that the sum of the numbers in the two sectors is prime? Okay, so we can figure out that sum. It's 3. We'll do 1 added to all of these. Now 5 added to them all. Okay, so probability, let's just count how many primes there are. 1, 2, 3, 4, 5, 6, 7. So 7 out of these 9 numbers are prime. So that is the probability. Say choice D. A 3-digit integer contains one of each of the digits, 1, 3, and 5. What is the probability the integer is divisible by 5? Well, to be divisible by 5, it has to end in a 5. And there's a 1/3 probability it ends in a 5, 1/3 probability it ends in a 3, 1/3 probability it ends in a 1. So therefore, there's a 1/3 probability it's divisible by 5. Choice B. Austin and Temple are 50 miles apart along Interstate 35. Bonnie drove from Austin to her daughter's house in Temple, averaging 60 miles per hour. Leaving the car with her daughter, Bonnie rode a bus back to Austin along the same route and averaged 40 miles per hour on the return trip. What was the average speed for the round trip in miles per hour? Okay. So it's 50 miles apart. We want to know rate times time is equal to the distance. Well, we know the distance is 100. If we can figure out the time, we'll figure out the rate. So time, if she goes 60 miles per hour for 50 miles, it takes her, 60 times time equals 50. The time there is 5/6. And then 40 times t is equal to 50. Call this t1, t2. The time going back is 5/4. Therefore, the total time is 5/6 plus 5/4. Common denominator there is 24. So common denominator of 24 multiplied by 4. Or no, common denominator is 12. 10/12. This is 15/12. So total time is 25/12 rate. So rate is 100 times 12 over 25. Rate, yeah. Then therefore rate is 4 times 12, which is 48. Yeah, so her average speed should have been 48 miles per hour. Choice B. A recipe that makes 5 servings of hot chocolate requires 2 squares of chocolate, 1/4 cup of sugar, 1 cup water, and 4 cups of milk. Jordan has 5 squares of chocolate, 2 cups of sugar, lots of water, and 7 cups of milk. If he maintains the same ratio of ingredients, what is the greatest number of servings of hot chocolate he can make? Okay. The relatively of what he has the smallest amount of milk compared to these, because 7 over 4 is less than 2 over a fourth. It's less than 5 over 2. So it's going to be all based on the milk. So how many servings can he make with that amount of milk? And it's 5 servings of hot chocolate. He can do 4 cups of milk, but for 1 serving, he needs, divide everything by 5, 4/5 cups of milk. So it's just about how many times does 4/5 go into 7? So really just 4/5 times x is equal to 7. X is equal to 5/4 times 7, which is 35/4, which is 8 and 3/4 servings. So yeah, I'd say you can make that many servings. Choice D. How many 3-digit positive integers have digits whose product equals 24? Okay, so if we break down 24, yeah, let's think about this. So yeah, prime factorization of that, 2 to the third, 8 times 3. So we could have 4 times 6 times 1. And the ways we can arrange this, there are 6 ways to arrange it. We could also do 8 times 3 times 1. And there are 6 ways to arrange that. And think of others. We could do 2 times 3 times 4. 6 ways to arrange that. 6 in there. Think about some other numbers that go into. There's 2 times 2 times 6, and there are 3 ways to arrange that. 2 times 2 times 6. Think about this. Have I used all the ways? So for 2, yeah, did it with 6 here, 8. Think if there's anything else. Any? Yeah, no, I believe this is it. Yeah, I'll say choice D, 21, because 6 plus 6 plus 6 is 18, plus 3 is 21. The positive integers x and y are the 2 smallest positive integers for which the product of 360 and x is a square and the product of 360 and y is a cube. What is the sum of x and y? 2 smallest positive integers for which the product of 360 and x is a square. Okay. Well, it's probably most helpful to find the prime factorization of 360. That's 36 times 10, or 6 squared um, times 5 times 2. Another way of writing this is 3 squared. Yeah, 2. Another way of writing this whole thing, 2 to the third times 3 squared times 5. 2 to the third. This is 9 times 5, 45 times 8 is, 360. That's it. So, I guess what are the two smallest for it's the product? Okay, so to make this a square, we just need this to be a square, so multiply by 2. We need this to be a square, multiply by 5. That'll get us there. So x is equal to 10. And then, so to make it a cube then, third, we want, that's already a cube. We want 3 to be a cube, so y has a 3 in it. And we need 5 to be a cube, so multiply by 5 squared. This is equal to y, which is 3 times 25 is 75. So x plus y is 85, choice B. The diagram represents a 7-foot by 7-foot floor that is tiled with 1 square foot black tiles and white tiles. Notice that the corners have white tiles. If a 15 by 15 foot floor is to be tiled in the same manner, how many white tiles will be needed? So in this arrangement, 7 tiles here, but 4 of them are white. 4 of them are white here. So in the 15, it's going to be there's going to be one more white tile than black tile, such that, and we know that 8 plus 7 is 15, so there will be 8 white tiles going across, and there should be 8 going down. So how many tiles will be needed? 8 times 8 should be 64, choice C. Two angles of an isosceles triangle measure 70 degrees and x degrees. What is the sum of the 3 possible values of x? So x could be 70 degrees. It could be also that, or the other angle could be 70 degrees, and x would be the other angle. So we know angles of a triangle are 180. X would be 40 in that case. Or the other angle could be equal to x. So we have 2x plus 70 equals 180. So 2x is equal to 110. Therefore, x is equal to 55. So some of the 3 possible values of x are 70 plus 40 is 110, plus 55 is 165, choice D. How many non-congruent triangles have vertices at 3 of the 8 points in the array shown below? So we could have one triangle with base like this that forms a right triangle like that. We could also have the 4 base triangle like this. We could have this like that. Does that make sense? No, because that's the same as that triangle. So of different congruent triangles with base 4, there are 2 we can make. Just rewriting this again here. Now let's consider with base 3. So we could make a triangle like that. We could make a triangle like that. We could if you had this triangle reaching like that, that definitely works. So there are 3 there that we can make. And lastly, triangle with one of its bases having a length of 2. So could make a triangle like that, could make a triangle like this, and could make a triangle like that. All of these are different triangles. So 3 we make there. So these are all the different ones. 3 could make 2 plus 3 plus 3 are all the different triangles. That adds to 8. So 8 non-congruent triangles, choice D. Andy and Bethany have a rectangular array of numbers with 40 rows and 75 columns. Andy adds the numbers in each row. The average of his 40 sums is A. Bethany adds the numbers in each column. The average of her 75 sums is B. What is the value of A over B? Okay. Well, the average of his 40 sums is A. So those 40 sums, A is equal to or rather, let me think about this. Those 75, so it should be true that 75B is equal to 40A. Because the number, yeah, the rows and columns should add up to the same thing. 40 rows and 75 columns. Let me just think about this. Yeah, this should be the case. So to calculate A over B is going to be 75 over 40 equals A over B. Simplifying this, 75 over 40 divided by 5, 15 over 8. So I would say choice D. How many whole numbers between 1 and 1,000 do not contain the digit 1? Okay. Well, what about digits between 1 and 1,000 that do contain the digit 1? So 1 to 99. We have, there's 1 through 9, and that just shows up once there. But then 10 through 19, 10 times there. And then it's 21, 31, all the way to 91. And number of times here is it's 8 times the digit 1 shows up. So in this circumstance, 19 times the digit 1 shows up. But then considering now when we go into 100 to 199, all of these digits contain the digit 1, and there are 100 digits here. So we have 19 here, 100 digits here. And then when we consider 200 to 299, there's going to be no difference from this and this, so there should also be 19 here. And same is the case with 300 to 399 and so forth, all the way to 900 to 999. They're going to be 19. And then 1000 contains 1. So it's going to be the numbers that do contain the digit 1 it's this 19 times the number of times it shows up. So so I believe it's 19 times 9 plus 100 plus 1 is 90, 81, 181, 181 plus 1, 182. So this is 282. But the numbers, this is asking us how many do not contain the digit 1. This is the amount that do contain the digit 1. It's going to be 1,000 minus 282, which is 728. Choice D. On the last day of school, Mrs. Wonderful gave jelly beans to her class. She gave each boy as many jelly beans as there were boys in the class. She gave each girl as many jelly beans as there were girls in class. She brought 400 jelly beans, and when she finished, she had 6 jelly beans left over. There were 2 more boys than girls in the class. How many students were in the class? Okay. Let's say, so there are X girls, and therefore there are X plus 2 boys. She had 6 jelly beans left, so she gave out 400 minus 6, which is 394 jelly beans. So it's got to be the case that X times X plus 2 times X plus 2, this is the total number of jelly beans she gave out. That's got to equal 394. So doing this, X squared plus, this is X squared plus 4x plus 4 is 394. Simplifying this, 2x squared plus 4x minus 390 is equal to 0. We can factor out 2 here to get x squared plus 2x minus 145 is equal to 0. So this is x. X and factors of 145, we could have x plus 15, x minus 13. So therefore, x is equal to 13. How many students were in the class? So we know there are 13 girls in the class, and then there are 15 boys in the class. 13 plus 2 is 15. So total students in the class is 13 plus 15, which is 28. Say answer choice B. The letters A, B, C, and D represent digits. If AB plus CA is DA and AB minus CA is A, what digit does D represent? So from this, so if we do B, these units digits will just give us A. From that, it's got to be true that B is equal to 0. Therefore, can we learn anything from this? 0 minus A is A. The only number where that's the case is if A is 5. So plugging that in, we have, to solve for C, 50, plugging in here, minus something gives us 5. Well, 50 minus 45 gives us 5, so C is equal to 4. Plugging that in here, we have 50 plus 45 that's 95. So D is equal to 9, choice E. One cubic foot cube is cut into 4 pieces by 3 cuts parallel to the top face of the cube. First cut is 1/2 foot from the top face. Second cut is 1/3 foot below the first cut. Third cut is 1/17 foot below the second cut. From the top to the bottom, the pieces are labeled A, B, C, and D. The pieces are then glued together end to end as shown in the second diagram. What is the total surface area of the solid in square feet? Okay. It'll be helpful then to find this. So we were told this is 1/2, 1/3, 1/17, but what's this fraction? Finding a common denominator here, 2, 3, and 17 all go into 102. So this is going to be 51 over 102. This is 34 over 102. This is 6 over 102. This is going to be just 102 minus 51 minus 34 minus 6. So that's 102 minus, this is 40, 102 minus 91 is 11. So this should be 11 over 102. So surface area of each of these areas here. So this, since we know this is 1, that's going to be 1, 1, 1, 1, and the bottoms are also 1. So we have 8 right off the bat there. And then we want to find the area of these sides. So for C, right here, it's going to be, C is 6 over 102. So yeah, that's going to be 3 times 6 over 102. Now for B, we have, B was the 1/3. So we have this 2 times 1/3. And maybe it's easiest just to speak in the 102. So 2 times 34 over 102. And then this is just going to be 30. This is 34 minus 6, which is 28 over 102. Now moving on to this one, this is going to be 1/2, and the other side is 1/2. So that sums to 1. And then this is going to be 51 minus 34. 51 minus 34, which is 17 over 102, the area there. So we've got those. And then D here, we have this. D is 11 over 102. Then we'll have 11 over 102 on that side, 11 over 102 on that side. So 3 times 11 over 102. And then on this side, it's going to be that 51 minus 11 is plus 40 over 102. So the sum here is going to be the area. So 8 plus 1 is 9. Then we have 9 plus, that's 18 over 102. Plus, that's 68 over 102. This is plus 28 over 102. And plus 17 over 102 plus 33 over 102 plus 40 over 102. So the sum of all of these, so 18 plus 68 is 86, plus 28 is 114. So we have 114 up there. 17 plus 33 is 50 plus 40. So this is 90. So then this is 90 plus 114. So this is 9 plus 90 plus 114 is 204 over 102, which is equal to 2. So it's 9 plus 2. Surface area should be 11, which is choice